Hi guys, welcome to this new video. Uh, in this video, we will understand the perceptron. Until now, we have had a discussion on what is a neural network and all the introductions behind it. But now we will start from understanding what is perceptron and it's since it is a building block of any neural network, and we'll also see what is the limitations that we have discussed in our introductory session. Right, that it cannot work on XOR data or non-linear data. So we'll see all those limitations in a visual way so you can understand the concept in a very uh, well manner. So let's start our video and let's understand the perceptron. So let me share my board. Yes, so let's understand how the perceptron is designed. What is the design of the perceptron, right? Since we already know that this perceptron is influenced by the neural networks or the neurons in the human body. So let's see the design, how scientists have designed this perceptron, which is a building block of any neural network. So So let me show you the actual design of perceptrons. Wherever you see, you will find this is a summation. And then here you will have another function. This is your output, and this will be your input. Right? Let's suppose x1, and we have also weight 1, x2 with weight 2, and let's consider this one. This is a bias. So this complete structure that you are seeing, this is actually the perceptron. This is actually the perceptron. This is the design of the perceptron, right? So now we'll understand when the data comes into the perceptron, how does it work, right? So this now you know this is the perceptron. Here the summation functions gives the data to this activation function, and then this gives you the output, the derived prediction, right? Where we say it have output. So this is your activation function, and this is your summation. Okay, so we'll understand it from one of the example. Let's say we have one data called x1 and we have a data called x2, and based on this data our output value is here. So let's suppose we have 10, we have 20, we have 40, we have 10, and then this is for class A and this is for class B. Similarly, we will have 25, again this comes under class A, Okay, so let's understand how perceptron works on this data. Right, this one. Right. So when you say the summation here, what actually it does is, what summation function does when all the input goes to this part, it actually does the dot product of its input variables values for each row with the weights. So here actually this summation function will do x1 into w1 plus x2 into w2, and then it will add a bias, right? We have not seen why we have taken this bias one and this one. We will discuss it further in upcoming videos. Right. And then let's say this as a z. So this z now becomes x1 w1 plus x2 w2 plus bias, right? And then this activation function, activation actually the work of the activation function is to make this value in certain range, right? So what does activation function do? Activation function will make a range, will keep the value in a range. We will learn a different activation function like ReLU, TANH. These are all the activation functions. So it will keep the value in a particular range, right? So this is your 0, this is your 1. Then whatever value comes as a dot product, it will try to keep in a range, either 0 or 1 or minus 1 to 1. This is the actually work of the activation function. So in this scenario, what it is going to do is, since we have two input x1 and x2, right? So it will go from x1 and x2, and then based on this prediction, because we based on this data, first it will put all this data to each of these variables, right? So x1 10 will go here, 20 will go here, bias will go 1 as a here. It will have some random weights, it will have some random weights w1, and during this training, based on this value, so for this one it is classified as a class A, right? So class, based on this value, whether suppose the value of this one it gives as a class A, or it does not predict as a class A, whether it is a class B, then based on this training it will try to calculate w1 and w2 and bias. So these are the three things it will try to calculate during the training time, right? During training time, it will try to calculate all these values. Once the training is done, then we will have W1, W2, and bias value, right? Let me put it right. And we have also, in the introductory part, we have also seen and discussed that this the drawback of perceptron is perceptron is it works on a it works only on a linear data, right? If you have any non-linear data, it does not give you the accuracy. It will have a very bad results, or the classification will also see that. So based on this one, if we try to recalculate this, let's take Z. Let's take since this is a two, we have a two inputs here. So I think you have seen this uh, equation somewhere when you might be learning the machine learning algorithm. So let's replace x1 with a, okay, or instead of x1, let's keep x1 as x. Let's keep x1 as x, and let's replace w weight as a and x1 as x, right? Plus weight 2 as a b. Let's consider weight 2 as a b and x2 as a y, and then b as a c. Okay, so what we did here is w1 is equal to a, w2 is equal to b, x1 is equal to x, and x2 is equal to y. Okay, so let's consider this. Let's consider, right? So when we consider this one, we get the value of z as this value. And if you see, this is the value of, or this is the equation of line here. If you see this, this is the equation of a line. I'll show you if you don't know this, and we'll also see. So when we have a two-dimensional data, then the value of the summation becomes line. If we have a three-dimensional, then it will become a plane. If we have a four-dimensional 2D, sorry, this is a 3D. If we have 4D, then it will become hyperplane. Hyperplane. Okay. Okay. So this is how the perceptron is, and this is what the perceptron actually, the the design of the perceptron is. Right. So let me take my ink, and now let me draw again once more. So this is your summation, and this becomes your activation function or a step function. This is your bias, and this is your two input with this scenario, and this will be your output, predicted output, right? So when it forms a line, then this z value, right, the z value that we have seen above, that it forms a line, it goes to the activation function here. So based on this activation function, actually it generates a region, which actually separates with that line, with this equation, right? So the actual how it when it creates a line, suppose this creates a line and some of the values are here, some of the values are here, and this is the equation of line your perceptron has found out. Okay, then how it works, the step function is your y prediction is a function of x, and it will give you class A or class B if z is greater than 0 or z is less than 0. So if z is greater than 0, it goes to class A, and if z is greater than less than B or equal to, then it's of class A. So this region will become class A, and this region will become class B. And this perceptron has found this line as a dividing region line, right? So I will show you all these details in as a tensor board playground, where you will understand this limitations and how it is not working on the non-linear data and how it works on the linear data. Right. So let me quickly show you in my tensor board. So if there is a playground tensor flow, so you can yourself see everything. So in this tensor board we have a different data category. If you see this one here, we have this category here. In this data, if you see, we have a linear data. We can see that it is linear data, and it can be divided through either by a line or a plane. But if you see these data, this is not linear data, right? So let's first understand the linear data, how perceptron works. So we know that for a neural network, if there is a neural one node, then it is called as a perceptron, right? So that is why we have not given any hidden layers here. If we provide any hidden layers, then this will not be called as a perceptron. This will be called as a multi-layer perceptron, because we have two neurons attached. So in this case, what I will do is I will just remove the hidden layers. This is your feature, and this is one uh, perceptron that it will try to train on this data, right? Then here we have taken the activation function as a sigmoid. I think you might be knowing the sigmoid is one of the functions which actually brings the data to a range in a form of probability, right? And problem statement we are taking as a classification problem. So let's run this one. Now if you see we run this, then this has actually converged, and it has a zero loss during the training, right? And testing also, it has now gone to the zero loss with 300, around 300 epochs, 350 epochs. And it has given you the complete region, how it has divided the data, right? With this line. Since it is a linear data, it now divided it, right? So this perceptron tries to divide it. But the flaw and the drawback of this perceptron was, which was already discussed in our previous introductory session, that the scientists so that this perceptron cannot converge on a non-linear data. So let's see the non-linear data, right? This is a non-linear data because it has no direct bifurcation which you can divide it, right, with this two input data. And let's run this one with everything, only we have changed the type of data. So if you see, while training, it is not able to converse. It cannot distinguish between these two datas, right? So both the values, if you see, it is trying to train, but it is not able to converse. So let's give it. In the earlier data, you have seen within 300 epochs, it has already converged. But now it has gone to almost 800,000 epochs, almost. Let's see, about 1,000 epochs, and the loss will be constant. If you see the loss, test loss and training loss, it has not actually converged. And why it is 50%? Because it is trying to bifurcate the data either by this line or by this line. So always you have a 50% wrong data if you try to use the single neuron or perceptron for the classification problem. So this will never converge. So this shows that we have a flaw in our perceptron. If we use the perceptron as a model to train, it will never converge and it will give you the very less accuracy as compared to the linear data. Since I will stop it now, since it has already gone to almost 2000, but it has not never converged. So this is what I wanted to show you guys in this video, and wanted to show you how perceptron structure is, how it works, and also its limitations. And you can also see in sklearn library, we already have a perceptron. Yes. So if you go to the sklearn library, the in sklearn linear model, this perceptron is present. So you can directly import this, call this perceptron, and try to uh, l- use it in your own data to understand how it works and how it has how it will be not able to work in your non-linear data. And if you see this perceptron class, I think this is also a part of the linear model. So it itself says that this is actually applicable for the linear problems, right? And which we have already seen in this network playground. So I hope you have understood what is perceptron and how perceptron actually looks, what is the design of the perceptron, and the drawbacks. Now in the coming video, we will see the outcomes, how we can train the perceptron, and what is the other multi-layer perceptrons that has actually overcome this problem. Right? So I hope you have some understanding on the perceptrons and its working. Thank you guys. Let's see you in the next video.